Welcome back. This is the last video on the first set of topics for chemical equilibrium. And this is pretty much for granted a type of question that will be on any exam, whether my class or someone else's class or some other standardized exam. Okay. What it's asking is you're starting the reaction with a certain concentration of N2 and H2, and at equilibrium, the reaction concentration is provided, and they're asking you to find the equilibrium concentration of these two components. Okay, that is very straightforward. We're going to do the same ice stable thing that we did for the acid-base buffer problem. Okay, first order always is balancing, so 1, 3, and 2. Good. So now let's go ahead and rewrite the actual equation one more time. 1N2 plus 3H2 going to 2NH3. Okay. And I'm just going to write the ice table I, C, and E. Okay. We are starting with 0.2 molar of nitrogen, right? And 0.15 molar of hydrogen. Well, when you start any reaction, there will be no product, so it's 0 for products. And then, as I said, change is always minus on the reactant side and it's plus on the product side, but you got to be careful. I said that when I recorded the earlier video when we did acid bases, is weak acid is that we need, since it was 1 to 1 to 1, there was no problem here. Nitrogen is one of the reactant, it's 1, so it's a minus X. Hydrogen is one of the other reactant, it also gets minus X, but there's 3 of them, so that's minus 3X. Ammonia is a product, so it gets a positive X, but there's 2 of them, so it's 2X. Okay? So the equilibrium would be 0.2 simply minus X, 0.15 minus 3X. What it really means is this is losing 1 time, this is losing 3 times as much product, and this is plus 2X. Here's where it gets interesting. Let's write the Kc expression, okay? Because we are doing 2 things in one problem. So let's write the expression and then come back and complete and then come back and finish the Kc part of it. So let's, Kc expression would be KNH3 squared over N2 times H2 All right, now let's come back. We have to find this value. Before that, we have to convert all these x's, right? Now, if you see, this is important. At equilibrium, the concentration of NH3 is 0.1. That is, what we're saying is that this 2x is 0.1. So what is x? It's important that you say that this whole thing is 0.1. So x is 0.05, I believe. I'm not wrong with my math. That's correct. So we know that, so this whole thing is 0.1, right? So NH3 on the top part is already known, it's 0.1. Don't do anything else, just put 0.1 here. Our goal now is to figure these guys out so we can put them back in the expression, right? So we know x is 0.05, right? So 0.2 minus 0.05 would be 0.2 minus 0.05 is 0.15. Well, you know what? Let me change this to like 0.16 or something like that, you know. Otherwise, this problem would be a 0 and it's just unnecessary issues. 0.16. So let's change this to 0.16. I know why, because, all right, 3 times 0.05 is 0.15, and it's just going to present an awkward situation. So 0.16 minus 0.15 would be 0.05 times 3. Yeah, it's 0.01, right? So now the important thing is whatever this value in x is, the whole thing is equal to the value provided. Okay, so 2x is 1. That's how we got the value of x. Now we got this. So now we can now go put all of this back in the expression. This is the equilibrium concentrations. This. So let's do this. I love this problem because it keeps you on the toe with a little bit of challenge. Well, this problem can really be only asked this way. There's not too many ways it can be asked. So I got 6.6 times 10 to the 4. I think it is 4. 1, 2, 3, 4. Yeah, 10 to the 4. Kc does not have a unit, so that's the value. All right, so you may have to again watch some of the videos more than once. Just don't try to take a visual photo of the problem and then try to memorize. It may work once for one problem, but not for the entire topic. So try to understand what's happening. And then if you have problems, ask me. I'm there to help. So this covers the first subset of topics for chemical equilibrium. There's only a couple that's left that I want to wrap up, but it'll be all part of next week's videos. But I'll post them just a little bit later. All right. So stay tuned for the second set of topics on equilibrium.